Coming to the third bit, the given equation is root 2 times of x square plus 7x plus 5 root 2 is equal to 0. The product of the first term and the last term is root 2 x square multiplied by 5 root 2, which is 5 multiplied by 2 multiplied by x square, that is 10x square. We need two terms such that their product must be equal to 10x square and their sum must be equal to 7x. 5x and 2x can be taken as the two terms. 5x plus 2x is 7x and 5x multiplied by 2x is 10x square. So 5x and 2x will be satisfying both the conditions. Root 2 x square plus 5x plus 2x plus 5 root 2 is equal to 0. X can be taken as common, root 2x plus 5, and here root 2 can be taken as common, root 2x plus 5 is equal to 0. Root 2 times of x plus 5 can be taken as common and the remaining terms will be x plus root 2. This is equal to 0. Root 2x plus 5 is equal to 0 and x plus root 2 is equal to 0. Root 2x is equal to minus 5 and x is equal to minus 5 divided by root 2. And here x will be minus root 2. Therefore, x is equal to minus 5 by root 2 comma minus root 2 are the roots of the given quadratic equation. Moving on to the fifth bit, the given quadratic equation is 100x square minus 20x plus 1 is equal to 0. The product of the first term and the last term is 100x square. We need two terms such that their product must be equal to 100x square and their sum must be equal to minus 20x. So 10x and 10x, if they are multiplied, it becomes 100x square. But 10x plus 10x is 20x. Here we have minus 20x. So minus 10x is minus 20x and minus 10x multiplied by minus 10x is plus 100 square. So minus 10x and minus 10x satisfy both of the conditions. So 100x square, on replacing minus 20x with minus 10x and minus 10x, we get this one. So 10x can be taken as common from the first and second terms. We get 10x minus 1 and minus 1 can be taken as common from the third and fourth terms. We get 10x minus 1. This is equal to 0. 10x minus 1 can be taken as common and the remaining terms will be 10x minus 1. This is equal to 0. 10x minus 1 is equal to 0 and 10x minus 1 is equal to 0. 10x is equal to 1 and 10x is equal to 1. X is equal to 1 by 10 and x is equal to 1 by 10. Therefore, the given quadratic equation has repeated roots which are 1 by 10 comma 1 by 10. Moving on to the fourth bit, the given equation is 2x square minus x plus 1 by 8 is equal to 0. This equation can be written as, by taking the LCM as 8, this becomes 8 times of 2x square is 16x square, 8 times of minus x is minus 8x plus 1 is equal to 0. So 16x square minus 8x plus 1 is equal to 0. The product of the first term and the last term is 16x square. We need two terms such that their product must be equal to 16x square and their sum must be equal to minus 8x. 4x and 4x. The product will be 16x square, and if I put a minus sign here, their sum minus 4x and minus 4x will be minus 8x. So minus 4x and minus 4x will satisfy both the conditions. 16x square minus 4x plus 1 is equal to 0. 4x can be taken as common from the first and second terms. 4x times of 4x minus 1, and minus 1 can be taken as common from the third and fourth terms. Minus 1 times of 4x minus 1 is equal to 0. Now taking 4x minus 1 as common, and the remaining terms will be 4x minus 1. This is equal to 0. We can write 4x minus 1 is equal to 0 and 4x minus 1 is equal to 0. 4x is equal to 1 and here also 4x is equal to 1. Therefore x is equal to 1 by 4 and x is equal to 1 by 4. Therefore this equation has the repeated roots which are 1 by 4 and 1 by 4.
Coming to the second problem, solve the following problems. The first bit given is John and Jivanti together have 45 marbles. Both of them lost 5 marbles each, and the product of number of the marbles now they have is 124. We would like to find out how many marbles they had to start with. Let us see the solution. Initially, assume number of marbles John had is equal to x. Totally, John and Jivanti together have 45 marbles. So, number of marbles Jivanti had is equal to total number of marbles minus number of marbles John had. Total number of marbles is 45 and number of marbles John had is x. So, number of marbles Jivanti had will be 45 minus x. Now, both of them lost 5 marbles each. So, number of marbles John had after losing is equal to x minus 5. Number of marbles Jivanti had after losing is equal to 45 minus x minus 5. This becomes 40 minus x. Now, according to the given condition, product of the number of marbles they now have is 124. So, this product x minus 5 times of 40 minus x will be equal to 124. This can be written as x times of 40 minus x minus 5 times of 40 minus x is equal to 124. 40x minus x square minus 200 plus 5x is equal to 124. Minus x square plus 45x minus 200, and 124 can be transposed to LHS and this becomes minus 124 is equal to 0. Minus x square plus 45x minus 324 is equal to 0. This can also be written as x square minus 45x plus 324 is equal to 0. Now the product of the first and last terms is 324x square. We need two terms such that their product must be equal to 324x square and their sum must be equal to minus 45x. Let us take 36x and 9x. The product of them is 324x square and the sum will be plus 45x. But here we have minus 45x. So if we put a minus sign here, then we get product as 324x square and the sum will be minus 45x. So minus 36 and 36x and minus 9x will satisfy the two conditions. X square minus 36x minus 9x plus 324 is equal to 0. Now taking x as common from the first and second terms, we get x times of x minus 36, and here we can take minus 9 as common. Minus 9 times of x minus 36 is equal to 0. X minus 36 can be taken common. The remaining terms will be x minus 9, which is equal to 0. This can be written as x minus 36 is equal to 0 and x minus 9 is equal to 0. So x is equal to 36 and x is equal to 9. Initially we assumed the number of marbles John had is x. If John had 36 marbles, Jivanti will have 9 marbles. If John had 36 marbles, Jivanti would have 9 marbles. If John had 9 marbles, Jivanti would have 36 marbles. So this is the solution of this problem. Coming to the second bit, a cottage industry produces a certain number of toys in a day. The cost of the production of each toy in rupees was found to be 55 minus the number of toys produced in a day. On a particular day, the total cost of production was 750 rupees. We would like to find out the number of toys produced on that day. Let us see the solution. Assume the number of toys produced in a day is equal to x. Number of toys produced in a day is equal to x. Now the cost of the production of each toy is equal to 55 minus number of toys produced in a day. Cost of production of each toy is equal to 55 minus number of toys produced in a day is x. So this becomes 55 minus x. Total cost of production is nothing but number of toys produced in a day multiplied by cost of production of each toy. So total cost of production becomes x times of 55 minus x. According to the given problem, total cost of production is equal to 750 rupees. We can write x times of 55 minus x is equal to 750. On multiplying, we get 55x minus x square is equal to 750. So transposing the terms on the left hand side to the right hand side, we get x square minus 55x plus 750 is equal to 0. Now the product of the first term and the last term is 750x square. We need two terms such that their product must be equal to 750x square and their sum must be equal to minus 55x. Let us take 25x and 30x. 25x multiplied by 30x is 750x square. 25x plus 30x is 55x. Here we have minus 55x. So if we put a minus sign here, we get the sum as minus 55x and the product as 750x square. So minus 25x and minus 30x satisfy both the conditions. So we can replace minus 55x with minus 25x and minus 30x. So this is plus 750 is equal to 0. X can be taken as common from the first and second terms. We get x minus 25, and here minus 30 can be taken as common. So this becomes x minus 25 is equal to 0. X minus 25 can be taken common, and the remaining terms will be x minus 30. This is equal to 0. We can write x minus 25 is equal to 0 and x minus 30 is equal to 0. So x will be 25, also x will be 30. Here we need to find the number of toys produced on that day. The number of toys produced on that day, number of toys produced is equal to, it can be either 25 or 30. Coming to the third problem, find two numbers whose sum is 27 and product is 182. So let us assume one number is equal to x. Since the sum of the two numbers is 27, the other number will be, total sum is 27 minus one number, which is x. So the other number would become 27 minus x. And the product of the two numbers, which is x times of 27 minus x, it is given as 182. So on multiplication we get 27x minus x square is equal to 182. Now transposing the terms on left hand side to the right hand side, we get x square minus 27x plus 182 is equal to 0. The product of first and last terms is 182x square. So we need two terms such that their product must be equal to 182x square and their sum must be equal to minus 27x. Let us take 13x and 14x. So 13x multiplied by 14x is 182x square. 13x plus 14x will be 27x. Here we have minus 27x. So we need to put minus 13x and minus 14x. Now their sum will be minus 27x and their product will be 182x square. So minus 13x and minus 14x satisfy both the conditions. So replace minus 27x with minus 13x and minus 14x plus 182 is equal to 0. X can be taken common from the first and second terms. X minus 13 will be remaining and minus 14 can be taken common. X minus 13 will be remaining. This will become 0. X minus 13 can be taken common and the remaining terms will be x minus 14. This is equal to 0. We can write x minus 13 is equal to 0 or x minus 14 is equal to 0. This gives x is equal to 13 or x is equal to 14. Therefore, the two numbers are 13 and 14.